Okay, so here we are with the second one, right? So again, we're going to go ahead, we're going to do the exact same thing, right? So here, this first gate, right, I can see that just A goes into it, and what happens is it gets negated. So at this point, it becomes the negation of A, okay? Now down here, A and B both go into this one, so at this point, what I have is A and B, okay? Now here, at this point, it goes ahead and splits. Okay, this one's going to go all the way to our last operator, so we're not going to worry about that for now. But here, this one goes up to this OR operator with our tilde A. So at this point, we're going to end up with tilde A or A and B. Okay? And then what happens is this goes into a NOT operator as it goes in here, and it becomes negated. So this gets a little bit long, but at this point the statement is going to be the opposite of tilde A and A and B. Okay? You see I got that double parenthesis at the end. If you prefer, you can go ahead and you can turn these into brackets if that makes it easier for you to read. So that's going to be our output right here that goes into our final OR statement. So finally I have this statement down here, and I have this statement right here that goes into an OR statement. So what I'm left with is tilde A, or I'm already running out of room. I'll be fine. Tilde A or A and B. And then I've got this other OR operator here, right? It's going to be OR, and then my other input is A and B, or A and B. Okay? So you can see this is a fairly complex diagram here, right? Now again, here it might be useful to use some De Morgan's law, because I think some useful things might happen here. But what we're going to go ahead and do is we're going to go ahead and just distribute this and see what happens, all right? So remember, when I distribute this, tilde tilde A becomes A. The OR statement becomes an AND statement, and then we have tilde A and B. Okay? And then OR A and B. Okay? So that went ahead and that kind of got rid of my first set of brackets here. Now if I want, I can go ahead and I can continue to distribute this and get rid of these brackets as well. And I'll end up with A and tilde A, right? Or tilde B, or A and B. Okay? Now the reason I do that here is, like I said, the statement was fairly complex. I could have built a separate column like I did for the last one, but now I can see that I'm going to need A, I'm going to need tilde A, I'm going to need tilde B, I'm going to need A and B in order to build my final statement. And then what I have to look at here is these ANDs and these ORs separately. Okay, so at this point, I don't know that really accomplished a lot for me, so I'm just going to go back. I'm going to ignore that. I'm just going to use this final statement as we build it along the way. Okay, so here I've got A, B, right, and then I'm going to have tilde A. I'm going to have A and B, sorry. I have A and B, right, and then I'm going to have tilde A or A and B, right? And then what I'm going to do is I'm going to start to label these just because I'm running out of room here. Right? At least two more. So what I'm going to do here is we'll color code a little bit, right? Here, we'll go ahead and we'll call this statement right here. We'll call this one Y, right? And we'll just reference that right here. This is statement Y. And then this statement right here we'll put as X, right? So you just have to remember that statement Y is going to be here at the negation, right? Y negates this statement, so negate that statement to get Y, okay? So here, we can go ahead and fill in our truth table now, right? So I'm just go ahead and switch back to my green here, right? So again, I'm going to have 0, 0, 1, 1, 0, 1, 0, 1, right? And then this first one here is going to negate A. So where A is off, it becomes on, and where A is on, it becomes off. This next one is A and B, so I'm going to look at my first two columns. Remember, for AND, both have to be on. So here, both are off, only one's on, both are on. Okay? Now here, this one takes the last two columns, the tilde A and the A and B column, and it does an OR statement. So remember, for an OR statement, just one of them has to be on. So here in this first one, again, I'm looking here at column 3 and column 4, right? I can see here that column 3 is on, column 3 is on, both are off, and here column 4 is on. So that's where I end up with that one. Now remember here, for this last one here, where I have tilde Y, I'm just going to negate that previous column. So where that's on, it becomes off, and where it's off, it becomes on. Okay? Now for my last statement, let me go ahead and take inventory again of what I'm looking at here. For my last statement for X, let's go ahead and switch colors again. X is going to go ahead and take a look at this column right here, right? And it's going to go ahead and take a look at this column right here. So I'm going to look at this column and this column. I'm going to say if one of them is on, then my final answer is on. And so here I can see that the second one is on, the second one is on, they're both off, the second one is on. They're both on. Okay, so this is going to be my final kind of truth value for this circuit based upon these initial inputs over here.